purpose of this video is to provide an overview of the Exploring Our Galaxy lab, and we'll walk through it here. Let's begin in the module. We'll scroll down until we find the template file for Exploring Our Galaxy. And you'll see there is a data file here as well. We will need to download both the template PDF and the data XLSX file. And then here are the questions. This will be where we upload our completed Excel file and answer the questions. So let's download these two files now. The download button is in the upper right hand corner for the template file. The template contains all of the instructions for the lab. Okay, that one's downloaded. Now let's go get the Excel file. I'll click on that and then click on download. Okay, now these two files are currently in my downloads directory. I want to save them to a place where I know that they're at and I can start editing them. Okay, now that I've saved them into a place that I know, I'm going to open both of the files and begin editing. Okay, now that I have both files open, I'll put one on top of the other. You'll see here in the Excel file we need to enable editing. I do that, and now you'll see there are data tables at the bottom here. Data table 09.01, 09.02, 09.03, and 09.04. Let's go back to data table 09.01 because that'll be where we start. And now let's switch to the template and see what this lab requires. First of all, this exercise is going to utilize Stellarium, and we're going to gather astronomical data that describes the distribution of stars and globular clusters in the Milky Way galaxy. And here are the things we're going to need. We're going to need Stellarium, we're going to need Excel, we're going to need the template file, which is the file we're currently looking at. We're going to need the data file, that is the Excel file that we just looked at. And then we're going to need the questions, which is where we answer the follow-up questions and also upload our completed Excel file. Okay, there's a lot of background information here. It's actually a very interesting story as to how we discovered that we live in a galaxy. I encourage you to read through the background information. And then here we are in the procedure. Now, part one of the procedure is a naked eye observation of stellar distribution. That is where we literally start Stellarium and we just look around the sky. You should notice that the stars are not evenly distributed through the sky. Instead, there are more stars in the band that we call the Milky Way. You can see that here in Stellarium. Let's go ahead and start it. Now, one of the first things that we're asked to do is fiddle with the settings that are in Stellarium. And if you go over here on the left-hand menu under the sky and viewing options here, click on that. And then under the sky tab, set the absolute scale to 1.5. That's over here. And we'll bump that up to 1.5. And then the relative scale, we want that to be 0.35. This will allow us to see stars a little better. And then we want to uncheck the box that says labels and markers. And after that, we'll close. And now let's get rid of the atmosphere by hitting A. Let's get rid of the ground by hitting G. And I'll get rid of the cardinal points by hitting Q. And now here we are, we have the sky to look at. And this is what I was talking about. You'll see the stars are not evenly distributed. There are fewer stars in this region of the sky than there are in this region of the sky. So you can see there's this band of stars that goes across the sky. And that's our galaxy. We're inside of our galaxy looking, in this case, looking toward the center of the galaxy, which is in this region right here somewhere. And there are more stars in that region than there are along the poles, which would be, say, this region right here. Okay? So that's what you do in part one. And then in part two, you actually do an empirical counting of stars. Let me show you how to do that. One of the things that it requests that we do is try to find Sagittarius. Now if you click F3, that brings up the search window, and you can type in SAGITTARIUS. Sagittarius. That's Sagittarius. And it puts it right in the center. Now you'll notice it says in the upper left-hand corner here, it says Sagittarius SGR. SGR is the abbreviation for the constellation Sagittarius. But it's not showing up here. We can turn on the constellations by going down here at the bottom. Click on these, or you can hit C to turn on the constellation lines, or you can hit V to turn on the constellation labels. And you can see right there, Sagittarius is right in the center, the way we would expect it. And then you can hit R to turn on the constellation artwork. And there's the Sagittarius outline there. Over here is Scorpius. You will need to know that constellation here a little bit because it talks about Scorpius. And it says the center of the Milky Way galaxy is somewhere in this region right here. Now there is a cluster of stars right there where I've got my arrow. That is not the center. That just happens to be a cluster in that region. But the actual center is somewhere in that region, but not at that point right there. I'm going to turn off the artwork, and I'm going to turn off, but I'm going to leave on the labels. I'm also going to turn off the constellation lines. Now, I know that I'm in the region of the constellation Sagittarius. Remember, that's SGR. So I'm going to zoom in, and if you'll look at the bottom here under FOV, you'll see it there, it says currently FOV 18.7 degrees. But as I zoom in, and how am I zooming in? I am rolling the mouse wheel. Now another way to do that is with the page up and page down buttons. But if I hit page up, you'll see that's the equivalent of zooming in, and if I hit the page down, that's the equivalent of zooming out. Now you can also use the up and down arrows, but hold down Control. So Control up and down allows you to move as well, zoom in and zoom out as well. Now what I want to do is I want to set the field of view, the FOV, to approximately 1 degree. And that's close enough. 0.999 is real close to 1. So what do I need to do? Well, I'm in the constellation Sagittarius, and if you look closely, you'll see the stars are moving. So one of the first things I need to do is I need to stop time. And how do I do that? I hit the K button. And if I hit K, that should stop time. And if you look down here at the bottom, you'll see time is no longer advancing, so it is stopped for me. Okay, now what do? I literally count the stars on the screen. So 1, 2, 3, 4, 5, 6, 7, 8. You go through and you count the stars on the screen. Now this is a region that is along the band of the Milky Way. So I will count the stars in Sagittarius, and then I will go to the data table. Here's the data table for the Milky Way regions, and I would put in the constellation SGR. That would be my constellation, and then I would put down my star count, whatever that happens to be. I'm just going to put in a number, let's say 50. All right, and I would do that for 1, 2, 3, 4, 5 total regions of the Milky Way, all along the Milky Way region. So if I go back here to Stellarium, I would zoom out one more time. And now I could pick another region in the Milky Way. Let's say I pick the region of Crux right here, and I will zoom in to Crux. I'll keep Crux kind of in the center. Now that I've got Crux in the center here, I will literally count the stars one more time, making sure that the field of view is the same in each case. After I do that, I'll go back here and put the name of the constellation and then the star count, whatever I happen to count for the number of stars. Now you'll see it says galactic polar regions. We also need to do a count in those regions. So let's go back to Stellarium. Once again, zoom out. If you zoom out far enough, you can see the Milky Way band going across here. Now there's a lot of labels up there. I'm going to turn those off. Once the labels are off, you can see the band going across like that. Well, if I look above and below the band, I'll zoom way out here. By the way, if you accidentally select something like I just did, you can unselect it by right-clicking. Now, because I've zoomed out so far, you can see the entire Milky Way that wraps around the Earth. So this would be the Milky Way there, and you can see it comes over here. It's fainter in this direction. This is because we're looking away from the center, but when we look over here in this region right here, we're looking towards the center. Now, if that's kind of confusing for you, you can't quite make out what's going on there. If I turn the ground back on, you'll see this is the entire Earth. So we've really zoomed out so far that we can see the entire Earth there. But if I zoom in and I get down here, well, now you can see part of the Milky Way is right here, and part of it is hidden down below the ground. So that's why I turn the ground off, so that I can see the whole thing. But what I want to do is I want to find the polar regions, and that's going to be a region that is in an area such as this. I'm going to turn the constellations back on. For example, the constellation Sculptor. So I would put Sculptor in the center here and zoom in to a region of Sculptor. Okay, once I get the field of view to right where it was before, and I want to try and get it exactly the same if I can, and that's close enough, then now I'll do my star count for this region. And if you're doing it correctly, it should be that the star count is going to be less in the galactic polar region than it is in the Milky Way regions. So I would record my next constellation here. This was Sculptor, and I don't know what the star count was. Let's say something like that. So I record the numbers there. Okay, you need to do that once again for 1, 2, 3, 4, 5 regions, and try not to pick the exact same constellation each time. These need to be different regions, but the bottom line is this bottom section is for the galactic polar regions away from the Milky Way, and then this is for the Milky Way region where the star count should be densest. And you should notice more stars in the Milky Way region than are in the polar regions. The next data table is the average star count. So I literally come over here and I would average these numbers for the Milky Way region, and that is what goes into that square right there. That's the average star count from the previous table for the Milky Way region and also for the galactic polar region. Now, like I said, if you've done it correctly, you should see a higher average star count in the Milky Way region than in the galactic polar region. Okay, let's move on then to the next part. And I'm back here in Stellarium. I'm going to zoom out one more time. And one of the things that you need to do is just look at the Milky Way, and you'll notice there are more stars in one area than there are in the other areas. So it looks to me like there's sort of a galactic bulge right here. And when I zoom in, I can see it even more clearly. And one of the things that you're asked to do is just estimate where you think the center of the galaxy is. You know, if I were guessing, maybe right around there is where I would think the center of the galaxy is. All right, well, I need to record that location, and the way you record that location is with right ascension and declination. You'll see here in the table, we need to estimate where the core, that's the center of the Milky Way galaxy, is located. And the first way we're going to do it is we're going to estimate the right ascension in hours, minutes, and seconds, and declination in degrees, minutes, and seconds. Now, when we do that, this area over here to the right-hand side, the decimal hours and the decimal degrees should populate themselves after we put numbers in here. The second way we're going to estimate where the center of the Milky Way is by using globular clusters, and we will write that in there after we complete that part. We'll write the right ascension and the declination of what our estimate is based upon the observation of globular clusters. And then the accepted. Now, this is one you'll have to actually go online and look up, but if you just Google coordinates of the center of the Milky Way galaxy, it will tell you the right ascension and the declination, and that's what goes down here in this bottom line. It is the accepted value that you find online. Okay, but our first one here is we need to estimate the center of the Milky Way galaxy, so let's go back to Stellarium, and I'll show you how to do that. If I pick, say, that point right there, I'll just pick something that's at that point right there. There's bound to be a star in that region. And now I will read off the right ascension and the declination of that point. And if you look here in the upper left-hand corner, you'll see RA/dec. And there's actually two lines that start with RA/dec. One of them says J2000, the other one says on date. The coordinates change slightly due to precession. So in either one of those that you wrote down, if the instructions say to write down the J2000, then do that one. If the instructions say to use the on date, then you do that one. But if the instructions do not specify, then either one of those will work. Okay, so that's the center of the galaxy. Now, another way to do exactly what we did there is to turn on the equatorial grid. And if you look at this, I have now turned on these blue lines that mark off right ascension and declination. Now, if I zoom in even farther, the lines become more and more refined. And I can just keep going until we reach a point that is really extreme. All right. Now, by doing that, what I've done is I have allowed the right ascension and the declination to show up around the edges here. And if you look there, you can see they're actually overlapping each other. But at that point right there, let's see, I've zoomed in as far as I can. That is negative 28 degrees, 15 minutes, 18 seconds. And I'm reading that along the edge over here. And the right ascension is sort of in between these two lines right here. This line over here is 17 hours, 50 minutes, 24.59 seconds. And this one is 17 hours, 50 minutes, 24 point something else, 24.6. And this one is 24.59. Yeah, you may have to move around in order to see those a little more clearly. All right, so somewhere between 24.6 and 24.59. So that's really, really close. So if I were estimating the right ascension, that's definitely 17 hours. That's definitely 50 minutes, and it's between 24.59 and 24.6. So that's within a tenth of a second. So let's just call it 24 seconds, and that's good enough. That's close enough. The declination, like I said, is real close to this line right here, and that line is negative 28 degrees, 15 minutes, 18 seconds. So I would go back to my table, and that's what I would record: the right ascension and the declination. Now, right ascension is in units of hours, minutes, and seconds, but declination is degrees, minutes, and seconds. The hours are always going to be between 0 and 24 hours. The degrees are always going to be between plus and minus 90. Okay, so I'll leave it up to you to fill that in. Then on the next table here, okay, so what we have here on the left-hand column is a list of globular clusters, and you can see there's several of them there, followed by the clusters right ascension and declination. Once again, hours, minutes, and seconds for the right ascension, but for the declination, degrees and minutes, the seconds don't really matter much for us here. Now, the first one you'll notice is M9. Let's go ahead and fill that in. Several of them have already been filled in for us, just as an example. But let me give you one more. Let's search for M9 and figure out what its right ascension and declination is going to be. So to do that, I go back to Stellarium, and I'm going to zoom out. And I'm going to hit F3, and I want to search for M9. Hit return, and there it is, M9. I'm going to zoom in, and I see, yeah, there is a little cluster there. I'll look at the right ascension and declination over here in the upper left-hand corner. I'm going to pick the J2000 one. That means the epoch is the year 2000. And the on date would mean the coordinates are good for today, whatever the day happens to be. Whereas the J2000 are the coordinates set specifically for 2000 point 0. So on New Year's Day, that would be the coordinates on the year 2000. And you can see they're pretty close. They differ only by a few seconds, actually. So 17 hours, 19 minutes, 12 seconds. So 17, 19, 12. I'm going to go back here and plug in 17, 19, 12. All right, the next one is declination. Let's go back and look at that one. That is negative 18, 30, 59. I'm rounding up the 58.5 to make it 59. So negative 18 degrees, 30 minutes, 59 seconds. So negative 18, 30, 59. So here I'll go negative 18, 30, and then the seconds don't matter. I could round that up to 31, and that would probably be a little closer. Notice as I did that, this over here to the right-hand side populated. So 17.320 is actually what 17 hours, 19 minutes, and 12 seconds corresponds to as a decimal. And negative 18.517 is what negative 18 degrees, 31 minutes corresponds to as a decimal. You can check that if you were to put 30 here, it should round to negative 18.5 because 0.5 is half and 30 minutes is half of 1 degree, so 18.5. Nevertheless, I'm going to turn it back into 31. All right, now the next one is M10. You would go look that up using the same technique. Bring up F3, type in M10, hit return, and it will put it right in the center for you there. And once again, you can read off the right ascension and the declination. All right, after you have done that and you have populated all of these here, then over here on the right-hand side, you will have all of these numbers filled in automatically for you. That's important for the next part because we're going to take all of these numbers here and we're going to create a plot. Let me go ahead and get a completed table here so that you can see how the plot should be. Okay, so now we have a completed data table 4 here and we're ready to create our plot. Here's what we do. Let's select the data, just the data here. And then once I have the data selected, I'll go up to Insert, Chart, and Scatter Plot with just the data points. And this is what you get. On the left-hand side here, the vertical axis is declination, and on the horizontal axis, this is right ascension. Both of these axes are not scaled properly. Also, we'll need to put a good chart title up here, and we'll need to add axis titles as well. So let's go ahead and start that. I can triple click right there, and this is going to be a plot of. All right, let's go up here to add chart element, axis title. We'll add one for the horizontal and one for the vertical. And now I can triple click on those and I can call that whatever I want. Remember, the one that is horizontal here, that's right ascension, and the one that is vertical is a declination. I'll leave it up to you to label those properly. Something else that we want to do is we want to change how the axis is scaled. So I'm going to click once on the axis and then right click and choose Format Axis. When it pops up over here, then you'll see, well, the minimum is -80 and the maximum was 60. Let's change that so it covers all values of declination, -90 to +90. Something else I can change here is you see that it has 3 decimal places. If I go down to number and change the number of decimal places to 0, then it looks better, in my opinion. We could do the same thing over here on the horizontal axis. When I select that, it automatically updates the right-hand side here. The maximum value that right ascension can be is 24 hours. So let's make right ascension go from 0 to 24 hours. And let's get rid of the 3 decimal places again. We'll use 0 decimal places. Now you may want to take this horizontal axis and you may want to put it down at the bottom. If you do, then the way to change that is where does the axis cross? You could change this, the axis value where the vertical axis crosses. It may be better to do this with the vertical axis and then come over here and set the value where the axis crosses the horizontal axis. We don't want it at 0. We want it at -90. And now when I do that, the horizontal axis is crossing the vertical axis at -90. So it puts it down at the bottom there. What you're seeing here, these blue dots represent the distribution of globular clusters in their coordinates of right ascension and declination. So you want to estimate where is the center of this, because all of the globular clusters are orbiting around the center of the galaxy, but they are not orbiting in circular orbits. They are orbiting very elongated orbits. But nevertheless, they should all orbit around the center. So at any one point in time, which is what we're looking at here, this is a snapshot of the position of the globular clusters. Of course, they move very, very slowly over the course of thousands to millions of years is how long it takes them to do the orbit around the center. But nevertheless, we're going to try and find where is the centroid of this. Now, you're just going to eyeball it. So if you had to take all of these and estimate where is the center, well, you could pick a spot. You know, maybe you want to pick a spot right there. All right, well, what is that coordinate right there? If that's the spot you wanted to pick, well, the declination looks like it's -10. The right ascension looks like it's maybe 16, 15 and a half, something like that. I'm just making up numbers. I want you to do a pretty good estimate as to where you think the center should be based upon this distribution of globular clusters. You can think of it this way: if these were all marbles glued to a piece of cardboard, and where would you need to put your finger to balance all of the marbles? That would be what the centroid is. If you think it should be here, over here a little bit, maybe out here, you're just making an estimate. Now, once you have that estimate, though, that's what goes back here in data table 3 for globulars. Write down your estimate in hours and degrees. You're probably not going to be able to fill in the minutes and seconds because you're just giving an eyeball estimate. After you've done all that, then you'll go and answer these follow-up questions that are in the template. You will need to answer these follow-up questions in the online quiz, and that's also where you will upload your completed data file. After that, you're done with the lab, and that completes the overview for the Exploring Our Galaxy lab.